In example 7, we looked at a case where we had an inconsistent system, meaning no solution existed. Now we want to consider a case where we have dependent systems and talk about what that idea means. So we can label our two equations as 1 and 2. And just since we haven't looked at a case this way yet, what we're going to do is take equation 1 and solve it for x. We'll do that by subtracting 4y over to the other side, because we can choose to solve either equation for either variable. And now what we'll do is substitute that statement in for x into equation 2. Which has still resulted in a single equation with only one variable. We can distribute through and continue working on solving for y. We'll get 56 minus 28y, and then plus 28y is equal to 56. So in this case, again, our two y terms cancel out, and we're left with 56 is equal to 56. The difference this time around is that this is a true statement versus last time what we were left with was a false statement. So if our variables all cancel out and we're left with a true statement, then what we're going to say is that we have infinite solutions that exist. And this is the type of case that we refer to as a dependent system. So an inconsistent system has no solutions. A dependent solution has infinite solutions. If we again think about this as our first method for identifying this case, which is the method where we apply either substitution or elimination, we can also look at this in a second way, which would be rewriting each of these equations in slope-intercept form. If we did that with equation 1, we would end up with y equals negative 1/4 x plus 2. And if we were to take equation 2 and also solve it for y, we would again end up with y equals negative 1/4 x plus 2. So even though the two equations, as they were originally stated, didn't appear identical to each other, when we go through that process of solving, what we see is that equation 1 and equation 2 are exactly the same, meaning that we have two equations with the same slope and the same y-intercept, meaning what we have are coinciding lines. So coinciding lines, or just the idea that if we were to graph equation 1 and equation 2, we would be graphing the first line, and the second line would just be graphed right on top of the first one. So we have essentially just the same equation being graphed twice. So what we can say here is that we have an infinite number of solutions, but it doesn't mean that every xy pair is a solution. What it tells us is that any xy pair is a solution as long as those values satisfy x plus 4y is equal to 8, or 7x plus 28y is equal to 56, which is really stating the same thing because those two equations are actually identical to one another if we just rearranged them and simplified things a little bit. So in order to write our solution, What we want to do is use a set of curly braces to say that our solution would be all coordinate pairs xy with a vertical line, meaning such that x plus 4y is equal to 8, and y is any real number. So essentially meaning y can be any value that we want, and then x is going to be determined by this relationship x plus 4y is equal to 8, which is given to us by equation 1. And then we can take that one step farther just to make it a little more clear, is that x has to be equal to negative 4y plus 8. So this is just equation 1 solved for x, and y is any real number. So essentially we can generate our infinite number of solutions by choosing any value for y, any real number, plugging that into this equation to then generate the corresponding value for x, so that we know in every single case we're getting an xy coordinate pair that satisfy both equations.